Welcome everyone. This webinar is a joint effort between Morningstar and Backwoods Solar. Today we're going to talk about Morningstar Solar Charge Controllers. My name is Mark McHenry. I'm joined here today by my Morningstar colleague Doug Grubbs. And from Backwoods Solar we have Sequoia Cross and John O'Hara on the line with us. We're going to be recording this webinar and we'll address questions at the end, so please text any questions you have in the chat box at the bottom of the GoToWebinar pane, and we'll address them as time permits. So let me start off by sharing some information about Morningstar and Backwoods Solar. For over 20 years, Morningstar has been a leading manufacturer of solar charge controllers and inverters with the same ownership, management, and distribution partners since the beginning. Our customers gave us an A rating for product quality this year's customer survey, and over 2.5 million Morningstar products have been supplied worldwide since our inception. Products are designed in the U.S. We have warehouses in Los Angeles and Taiwan, and we have numerous patents and trademarks. Our co-host, Backwoods Solar, is a Morningstar partner, and they have many years of experience with Morningstar products. For over 30 years, Backwoods Solar has been a leading supplier of off-grid components, including modules, batteries, charge controllers, inverters, and other balance of system products. They don't just supply products, they provide custom design service and after-sale technical support. And Backwoods Solar technicians personally use many of the products featured on backwoodssolar.com. So before we take a deep dive into charge controllers, let's start with some basics about the purpose of a charge controller. Charge controller in a PV system maintains a battery at its highest state of charge while protecting the battery from overcharge by the array. Some controllers include load control with low voltage disconnect to prevent over-discharge of the battery from system loads, and this maximizes available battery capacity and cycle life. They can also provide system status indicators with meters and LEDs to display battery voltages, current, system operating temperatures, and alerts. And some can facilitate remote communications with power systems. The charge controller generally represents about 10% of your total system costs, but a failed controller can cause complete failure in your entire solar system. So you definitely don't want to try and cut corners on the 10% that the rest of your system relies on. At a minimum, loss of power and damaged batteries can result from a failed controller. And you can have the best batteries and the best modules in the world, but they're only as reliable as your controller. And these are the top off-grid applications where Morningstar charge controllers are used. I believe we have a lot of residential installers on the line with us today, and Morningstar has many years experience with residential applications. Our controllers also regulate batteries in industrial applications that you see on this slide. And on the next slide, we're going to take a look at the stages through which controllers regulate battery charging. Since there's no PV to charge batteries at night, just before morning, batteries are typically at their lowest state of charge. Then when daylight breaks, bulk charging or normal charging begins. Bulk charging is a high charge rate that charges the battery up to a voltage resulting in a state of charge of about 80 to 90%. And at this point, when the battery is nearly fully charged, most of the battery's active material has been converted to its original form, and current regulation is required to limit the amount of overcharge supplied to the battery. So for the next 1 to 3 hours, the battery goes through absorption charging, whereby charge current is reduced to maintain the battery voltage at a certain regulation voltage. And when absorption charging is complete, the battery is at about 98% state of charge. At around 98% state of charge, charging voltage is lowered slightly to the float voltage, and the charging current is set to a very low rate. This stage is called float or trickle charging to finish the battery charging. The float charge rate must be less than the self-discharge rate or the battery will be overcharged. And for flooded open vent batteries, an equalization charge is used about once a week or once a month to maintain consistent specific gravities among individual battery cells. The more deeply a battery is discharged on a daily basis, the more often equalization charging is required, right here that you see on the chart here. Again, this is for flooded open vent batteries, not sealed or valve regulated batteries, which can be damaged by equalization. So now we've completed the general overview on charge controllers and the battery charging states. I'm going to highlight the common characteristics that pertain to Morningstar controllers. So all Morningstar controllers have a 5-year warranty. We're supported by Backwoods Solar to maintain inventory, short lead times, technical support, and assistance with selecting and integrating our charge controllers with modules, batteries, accessories, and other components of off-grid solar systems. Not only are our controllers manufactured in a certified ISO 9001 facility, but our director of manufacturing, who's been here 18 years, does an outstanding job to make sure our products are inspected and approved under strict quality control guidelines. As some of you might know, Morningstar controllers are passively cooled and have no fans or moving parts. That can be a point of failure. This is important, and I can share a quick example I think people can relate to. If you've ever looked inside your computer at the cooling fan, if you have, chances are you saw all types of dust and debris that the fan has drawn in. So that's not good for a computer, and likewise it's not good for a charge controller, especially one that you want to last for 5 years or more. And if the fan or other cooling part breaks or slows down, as they sometimes do, the controller gets hotter, and that's bad for electrical components. And this can ultimately affect or actually shorten the life of the controller and decrease its efficiency. Regarding operating temperatures, our controllers perform well through a wide range of temperatures from well below freezing to well above room temperatures. And they have lightning and transient surge protection. This offers a degree of protection from nearby lightning, and this protection will not degrade over time. It has a faster response time than MOVs, but if you want protection against larger surges, you might want to install an MOV externally. Morningstar is easy to integrate with components of other components of a solar installation, including almost all types and brands of solar modules, batteries, inverters, and other balance of system components. And Morningstar controllers are easy to operate and maintain. Our customers say you can set it and forget it. No need to set IV curve sweep times. They have a small footprint. They're lightweight for their capacity. Firmware can be updated in the field, on-site in a few minutes. It's compliant with FCC regulations to ensure that there's no noise interference caused by the controller. In terms of scalability, our controllers can be connected in parallel without using a communications link, since we have very accurate voltage regulation and voltage sensing. Last bullet on this slide, environmental protections associated with Morningstar controllers include epoxy encapsulation and conformal coating. I'm going to show you some pictures of these environmental protections on the next slide. So to illustrate a point about epoxy encapsulation, we're going to use an example of our SunSaver controller here. In this picture, the cover is on the controller, but now I'm going to show you a picture with the cover off so that you can see the epoxy underneath it. So this epoxy protection is like a hard plastic that completely covers and isolates all the electrical components and the PC board. This protects against humidity and airborne particles. This is the best practice for electrical device manufacturing. Many controller brands don't have this protection, but Morningstar controllers do. Conformal coating is applied by a spray that goes over the circuit boards to protect against dampness and corrosion. This nozzle that you see right here sprays a fine mist of epoxy or silicone coating. This spray is almost invisible, so I added a graphical representation to accentuate it a bit in this picture so you can see it. This nozzle will travel up and down this circuit board across the whole board, applying a coating that will provide additional protection against moisture, dust, and other contaminants. We also use surface mount components that are precisely assembled by machine, not hand assembly. So this makes for a very reliable, high-quality product. And now let's go to the next slide to talk about the different types of controllers that Morningstar manufactures. So you can see from this table that Morningstar manufactures pulse width modulating, or PWM controllers, and maximum power point tracking, or MPPT controllers. And you can see the attributes of each of these types of controllers. PWM controllers tend to be smaller, and they generally operate close to battery voltage, which is usually below maximum power voltage, whereas MPPT, like the name implies, these controllers operate at the maximum power voltage, so they can provide more power when the array input voltage is higher than the battery system voltage. You tend to see more and more MPPT usage for installations that employ large modules or arrays, and the superior performance of the MPPT over the PWM increases during cold days when the PV voltage is higher and or when batteries are at low voltage. Choice between PWM and MPPT is determined by your module sizes, your power needs, and weighing the cost to harvest additional power. I'd like to share some graphs on the next slide to further illustrate the differences between PWM and MPPT, and more specifically, Morningstar's TriStar MPPT technology. To illustrate the difference between PWM and our TriStar MPPT technology, we have the graph on the left, which represents current versus voltage, and the graph on the right, which is power versus voltage for a 12-volt module. Associated with all modules and arrays is a maximum power voltage. That's right here on the IV curve and right here on the power graph. And this is where the greatest power from the array is possible. So a PWM controller doesn't include DC to DC conversion from the array to the batteries, so it will operate below the maximum power voltage as shown in the gray area on the graphs, depending what the voltage of the battery is at that given point in time, here on the IV curve or here on the power graph. So if we're here in the battery was, say, near 10 volts, you'd only have about this much power, which is a lot less than the maximum power point. TriStar MPPT controller, however, has DC to DC conversion, meaning it accepts and converts high voltage power to low voltage power, but the amount of power is still the same, minus 1% due to conversion efficiency. So MPPTs operate at this maximum power voltage and will never, or excuse me, they'll actually deliver more power to charge batteries than the PWM. So this is sometimes referred to as MPPT boost, which will typically be 5 to 25% or more charging power than PWM controllers. MPPT also allows the use of lower cost, high voltage PV modules and higher voltage strings for wire cost savings. And TriStar MPPT technology is different than other MPPT solutions found in the industry. MPPT technology among brands can vary considerably. One important aspect of an MPPT controller is that they should operate at the maximum power voltage as often as possible. TriStar MPPT controllers make fast sweeps of the entire IV curve in less than a half a second. So this allows it to sweep more frequently to better maintain the true maximum power point. So when considering an MPPT controller, it's important to know how many seconds or fractions of a second it takes to sweep the IV curve and how often sweeps take place in a day. Some MPPT solutions with slower and less frequent sweeps might take a full minute to sweep and might only sweep a few times a day, and thus have problems accounting for daily temperature and irradiance or mixed string voltages due to shading or mismatched modules. We recently had a customer tell us he harvested over 20% more power under the same conditions when using our TriStar MPPT controller versus another MPPT brand with similar voltage and amperage ratings. And before taking a look at several of the Morningstar PWM and MPPT controllers, let's go to the next slide to cover another important feature, and that is efficiency. Efficiency is a ratio of controller output power divided by controller input power from the PV array, or another way of looking at it, how much power is lost by the controller in the form of heat because of inefficiencies. So you see how on these MPPT controller graphs of efficiency versus output power, the Morningstar controller on the left provides significantly higher efficiency at both low and high output power levels. So whether it's low or high, okay? Whereas the controller on the right's efficiency drops off dramatically at output power levels away from its peak efficiency, which is marked by the red lines here. So if this is the peak efficiency, you have the red lines here away from the peak efficiency, and you can see a considerable drop-off, whereas Morningstar is pretty much straight all the way across. You can see how the controller on the left reaches peak efficiency very, very quickly, and then, like I said, it just remains high throughout the output power ratings. So high efficiency during low power output periods and lower turn-on power levels is critical to supply as much charge to the batteries as possible when it's needed the most. And high efficiency during higher output power periods is important to ensure that the controller doesn't overheat. Other MPPT brands have been shown to have more than 2 times the energy losses at higher output levels. Not only is power lost, but it gets transformed into heat, thus making their controllers very hot. When a manufacturer quotes you a conversion efficiency for a controller, you need to know the output power at which that efficiency was calculated, and also how much that efficiency will vary at higher output levels. In grid tie, a 0.25% difference in efficiency is a big deal. So we're talking about 1% to 3% here. Thus, 2 things when you look at efficiency. Don't just consider peak efficiency, consider efficiency throughout low, medium, and high output power levels. Second, appreciate what might be perceived as a small difference. 99% and 98% might sound pretty similar, but when you're talking about efficiency, another way to look at this is twice as much energy is being lost in the form of heat in the 98% scenario. And heat is an enemy of electrical components, and it impacts the life of the controller. TriStar MPPT controllers with TriStar technology may provide 2 to 7% or even more charging energy on a daily basis from the same array compared to other MPPT controllers on the market. This is because of better energy harvest from better tracking and better efficiency throughout the range of output power levels. Now let's talk about another very important topic concerning Morningstar MPPT controllers, and that's oversizing PV arrays. We tend to get a lot of questions about this. So I want to make a very important point about oversized arrays and Morningstar MPPT controllers. This applies to Morningstar MPPT controllers, not PWM controllers, because PWM controllers you can't exceed their current ratings without potentially damaging the controller. So the point I'm going to make here about oversizing only applies to our MPPT controllers. And I'm going to use the SunSaver MPPT controller as an example, but this point about oversizing also applies to our TriStar MPPT and TriStar MPPT 600-volt controllers. And in this example, we have a system that has a 240-watt module that is delivering power to a Morningstar MPPT controller that has a nominal maximum operating power of 200 watts, as you can see here. And since we're using a Morningstar MPPT controller in this example, this array with a 240-watt rating can be used with our MPPT controller that has a lower 200-watt rating, and you won't damage the MPPT controller. You can size your PV arrays to input power to Morningstar's MPPT controllers well above the controller's nominal maximum operating power rating without damaging the unit and without causing the charging current to exceed the maximum output current rating. The controller will limit output current and will run at 100% of rated current output and not higher. The controller was designed with this power shaving capability, and when oversized, it doesn't void the warranty. And you can read more about this white paper, or actually we have a white paper, and I've included a link here at the bottom of the slide, so you can read more about this by going to this link here. And just bear in mind that whenever you whether you oversize your arrays or not, you still have to adhere to other operating guidelines in the Morningstar manual. For example, don't forget about VOC ratings. You must never exceed open circuit voltage limits on the data sheet or manual, because this will damage the controller. But staying on point about oversizing, let's take a look at a graphical view that will clarify what's going on here. This graph here illustrates the output power levels of a SunSaver MPPT controller, comparing a 200-watt module represented by a dark blue line. So you have power on the left, and you have time of day on the x-axis. Okay, and it's comparing the 200-watt module with a 240-watt module in this light blue line here. And this is operation on a clear, sunny day at standard test conditions and maximum power. So if using the 240-watt module, although the power being delivered to the battery is limited to 200 watts, and the red area here at the top of the production curve represents lost power, the larger 240-watt module is still harvesting more energy than the 200-watt module, as shown in the green areas. The larger module will provide better production with no power shaving early and late in the day as compared to the smaller module. And in this case, almost twice as much energy is gained in this green area than is lost in the red area. And you get about 12.5% more energy available to charge your batteries from the 240-watt panel than you would with the 200-watt module. But what happens on days when it isn't clear and sunny? So this graph is using real array data to depict what happens on days when intermittent sun and clouds for the 200-watt and 240-watt modules. On these days, there's going to be little or no power shaving, and the extra power will serve the battery well with more energy harvest. On this day, for the 240-watt module, there's less than 1% loss due to power shaving. That's the energy above the red line. So almost all the excess power over the 200-watt module can be utilized for charging. So systems that experience a lot of intermittent sun and shading during the day are very good candidates for oversized arrays. And with that said, let's now take a closer look at some Morningstar's PWM and MPPT controllers. Here you have our family of PWM controllers. From largest to smallest, we have the TriStar, ProStar, SunSaver, SunSaver Duo. That's used for boats, mobile homes, and RVs. And then we have the Sunlight, Sunkeeper, and SunGuard. And let's just highlight two of these PWM controllers that might be most relevant to our audience. So we're looking at our SunSaver here. The biggest differentiator with this controller is that it's suitable for use in environments that contain flammable chemicals. So this is often used at remote oil and gas sites to power electrical devices, meters, and process control equipment. And this controller is very easy to carry. It's only about 6 inches long and weighs about half a pound. Next we have the TriStar. This is a very popular PWM controller. It supports 3 operating modes: solar charging, load control, or diversion control. But just to head off a question that comes up, you can't use one TriStar to perform all of these operating modes in your system at one time. Therefore, if, for example, you needed charging control and load control in your system, you'd have to install 2 TriStars. It's ideal for solar, wind, or hydro installations. It operates at full ratings to 60 degrees centigrade without the need to derate. Versions for this controller include 45 amp and 60 amp at 12 to 48 VDC. It's used in a lot of residential applications, also lighting, traffic, and railroad applications. It has a lower cost per watt than other controllers, and it's equipped with extensive electronics protections, and it has an RS-232 connection for custom settings, data logging, and remote monitoring. On the next slides, we're going to go ahead and display our MPPT controllers. From left to right, we have the TriStar MPPT 600-volt controllers, the TriStar MPPT, and the SunSaver MPPT controller that we mentioned in the previous example about oversizing. And here you get a closer look at the SunSaver MPPT. It's about 7 inches long and weighs just over a pound, so it's very easy to handle. It's rated for 15 amps. Maximum input operating power is 200 watts and 400 watts for 12-volt and 24-volt battery systems, respectively. It provides a 5 to 25% charging boost and increases battery life. Some people use this with a 24-volt nominal PV array to charge a 12-volt battery, and this controller reduces power losses in long wire run systems. Peak efficiency you see here is 97.5%, and this efficiency doesn't drop off significantly throughout the output power range. The efficiency is not as high as our TriStar MPPT, but this is a popular, cost-effective controller for smaller applications. It's used in residential, lighting, traffic, and railroad applications. And here's the TriStar MPPT. It comes in 30 amp, 45 amp, and 60 amp versions. For some reason, people seem to forget that this comes in a 30 amp version, probably because the 30 amp version came out most recently. So you may want to make a note of that. All versions of this controller support 12, 24, and 48 volt battery systems. The peak efficiency of 99% is among the highest, if not the highest, in the industry. This TriStar MPPT is commonly used in residential, telecom, and railroad applications. And now our largest controller, the TriStar MPPT 600-volt controller, was created for off-grid PV wind or hydro systems with input voltages greater than 150 VOC with long wire runs or greater radial bends from the power input to the controller. If you install this controller and later on your load capacity changes and you need to increase the size of your PV array, you can add modules incrementally without incurring string sizing issues associated with smaller controllers. And its peak efficiency of 97.9% is very high for a high voltage controller. It's preset for 48 VDC battery systems, but it's custom programmable for other battery system voltages. The advanced internal processor within this controller enables faster sweeping, so this 600-volt controller will sweep the PV array as fast, if not faster, than its 150 volt version predecessor controllers. It sweeps in less than a quarter of a second. Up to 4 TriStar MPPT 600 volt controllers may be used in parallel to manage charging from a single source input. And in such parallel arrangements, the controllers will be synchronized to act as one large aggregated controller. And what this means is that all functions are synchronized among all of the controllers, included but not limiting to MPPT, charging, indications, aggregate data, battery sense, and battery temperature readings. It's used in residential and telecom applications. You see pictures of the standard version and the version with a PV and battery disconnect box on the far right. And on the next slide, I'm going to show our newest version of this product. So this is the newest version of our 600 volt controller, which has an added manual PV disconnect transfer switch and grid tie inverter terminals. We anticipate availability for this controller in Q2 or Q3 of 2015. This controller is one of the main components in a grid-tied battery backup solution to provide backup power during an outage for grid-tied solar systems. So up until now, everything that we've been talking about was associated with off-grid. But now we're changing gears and we're talking about grid-tied. Another phrase you'll hear to describe this application is DC coupling to retrofit battery backup in grid-tied systems. So power from the array goes into this controller and it's directed to a battery bank when the switch is in the battery backup controller on position. So we've kind of highlighted this switch here. So you can see battery backup controller on. And then it goes to the grid-tied inverter when the switch is set to the grid-on controller off position, which is right here. And to the right, we have a diagram that shows PV power coming in and this power being delivered through the switch to the 600 volt controller for battery backup, again when the switch is in the battery backup controller on position. This PV disconnect transfer switch inside the controller is a 30 amp double pole double throw switch. It's a break before make switch, so it will connect incoming PV power to the controller or to a grid-tied inverter, but never both simultaneously. And it meets NEC standards for switches and disconnects. So now that we've covered the specifics and features of this controller, let me describe a scenario that will help everyone appreciate how this controller is applied in a grid-tied battery backup solution. If, for example, you installed a grid-tied solar PV system like the one you see in this picture, everything works great as long as the utility grid is working. The next slide includes a wiring diagram that shows how power is being supplied in this case. So this is a diagram of a simple, efficient grid-tied PV system for the house you just saw in the previous slide. The DC power is supplied from the PV array, goes to the string inverter, which converts the power to AC power and sends needed power to your main service panel. Any excess power is sent back to the utility company for a credit, which reduces your electric bill. So this is referred to as net metering, or some people like to say running your meter backwards. But if you're a PV installer who's installed a system like this, you probably encountered the question, what happens when the grid goes down? And if you didn't get asked that question, you should make people aware of the answer so they won't feel misinformed and disappointed when they find out for themselves later. So what happens when the grid goes down? When the grid goes down, the string inverter, whose operation is dependent on the grid, doesn't deliver power to the main service panel or the utility. Thus, you have no power. Almost all the residential and light commercial grid-tied systems that have been installed in the U.S. and Canada over the past 2 decades rely upon utility power to operate. Weather and infrastructure events have caused a growing number of consumers to experience the fact that their grid-tied solar system is useless during a power failure when the array is left stranded. So for this very scenario, we can apply the TriStar 600-volt controller with DC transfer switch, and I'll show you how we do this on the next slides using some schematics so you can see how this all works. So in this slide, you see that we've added a 600-volt controller with a PV disconnect transfer switch to the system. Also, we've added a ground fault protection device, a battery bank, backup inverter charger, and an automatic AC transfer switch that directs power to a critical load sub-panel here. And note the 600-volt controller with its orange transfer switch is in the battery backup controller on position. So with the switch in this position, the DC power flows through the controller and to the batteries, and then the batteries power flows from the batteries to the backup inverter charger, and then this converts the DC to AC power and it sends it to the automatic AC transfer switch, which directs the power to the critical load sub-panel. So the critical loads can be run such as your refrigerator, some of your lights, your computer, television, and cell phone charging outlets. So during a grid outage, you have emergency power from your batteries that get charged from the PV array. And when the grid power is restored, turn the controller's transfer switch to the grid on controller off position over here, and the electricity flows according to the schematic that I'm going to show you on the next slide. In this example, when the grid is working again, we're looking at the system with the controller's transfer switch in the grid on controller off position right here. The flow of power in this case looks very similar to the first diagram of the simple grid-tied home we saw a few slides earlier. So DC power from the array doesn't get regulated by the controller, which is switched off. The switch directs the power to the string inverter and outflows AC power to the main service panel and excess power to the utility for a credit. Power from the main service panel goes to the critical load sub-panel, and power also goes to the backup inverter charger, which converts AC power to DC power to charge the battery bank. So the battery bank will be charged and ready when you have the next grid outage. And here are the advantages of Morningstar's solution to grid-tied battery backup as compared to AC coupling. Number one, backup system inverter and battery bank sizing is completely independent from the grid-tied inverter. It can be sized to suit customers' needs and budgets. It uses 4-stage charge voltage regulation to attain 100% state of charge when sufficient solar resource is available. It can handle oversized PV inputs with no harm to the controller, which allows for greater energy harvest on cloudy days versus many AC-coupled solutions. As far as scalability, much smaller doesn't necessarily mean much less. Scalability of the TriStar MPPT 600-volt controller in this system can make it a much more cost-effective solution, providing significantly more kilowatt hours of charging for every dollar spent. And this solution offers a simple way to provide single-phase backup power on 3-phase systems. It's the lowest total cost for entry-level systems. It can be installed in subarray wiring for large arrays, and additional units can be installed in parallel for increased battery charging and load support capacity. Your installation may very well need ground fault protection. So here's some things to consider. The Morningstar ground fault protection device can be used in these cases. Depending on your state or province, you may need arc fault protection. And again, this is a manual switch here that we're talking about. So if you're at home, when the power goes out, you simply go to the switch and set it to battery backup controller on, so your PV array can power your batteries. And regardless of whether you pull the switch, you can configure your battery backup power to go on immediately and stay on as long as you have battery power to power critical loads. But you need to turn the switch to backup battery controller on so the PV array keeps the batteries charged. Non-critical loads will be without power, so you may see clock lights blinking on non-critical appliances, or non-illuminated night lights and wall lights that remind you that the grid is still down. And if you're away from home on vacation, you'll have to have enough battery backup power to last until you get home and see that the power is out so you can operate the switch, or have a neighbor or other designated person move the switch to the battery backup controller on position in your absence. So we've covered a lot, and I'm going to end with a couple of summary slides about our products and accessories, and then we'll get to the Q&A. To summarize the controller products that we offer and the types of applications that they are typically associated with, I wanted to share this chart. This is a general guideline, so you're not restricted from using any of our controllers in any applications as long as you adhere to controller operator manual recommendations to meet your application requirements. Lastly, this slide displays our controller accessories, and if you go to our support site, support.morningstarcorp.com, and you search for accessory, you'll see a chart that will let you know which accessory is compatible with each Morningstar product. So we've reached the end here, and now let's take a look at the questions. So what I'm going to do is, why don't I read the questions that came in, and Doug, Sequoia, and John, I'll direct them to you as appropriate as they can be answered. So let's take a look at what we have here. See if I can open this up. Okay, I have a question that came in that says, what I am seeing with the grid-tied backup is that it requires manual switch on of the PV charger and then another manual switch over. So I think what might be going on, I'm going to give my 2 cents here, Doug. I'm trying to interpret this, and then you can pipe in. I think what you might be referring to is the AC transfer switch. So is there anything you want to add to that? Yes, there's the switch on the controller is a manual switch, and then the other switch is actually in the diagram we drew out here. It could be done a few different ways, but the way we had it was a automatic AC transfer switch.
Well, it was just depicted as a manual transfer switch, but it could be automatic or manual depending on your inverter, whether your inverter includes it. Whereas, so it was just really a picture to show the transfer, whereas you would probably have a built-in. Several inverters are available that have built-in automatic transfer switches, and then you just have the bypass. That would be a manual grid bypass switch, which is separate. So that diagram was just used to show the switch and how it how it would be operated. Not really just a depiction. So it can be where you can use a manual AC transfer switch or a automatic AC transfer switch in your inverter, and you would just go by the inverter manufacturer's recommendations as far as installing the inverter backup system.
Okay, thanks for clearing that up. We have quite a number of other questions that came in here. Question from Larry says, how about charging lithium-ion batteries? You want to take that,
Sure.
Doug?
We have custom settings capabilities with all of our controllers. Every aspect of the charging, timing, the voltage regulation set points, and whether you want to eliminate or change the temperature compensation is all available. You can also not connect the RTS to a remote temperature sensor. That would eliminate the temperature compensation if needed. We're about to release web pages on lithium for more information on how to use our controllers with lithium batteries. So all the custom settings can be used to work with lithium batteries. Though it's really very important that it's all set correctly and according to the battery manufacturer's requirements.
Terrific, thanks. I have a question that I'm going to pose to Backwoods Solar, to Sequoia or John. Question here is, what are the lead times in receiving Morningstar products from Backwoods Solar? Is Sequoia or John still there that they can address that?
Yeah, I'm here. This is Sequoia. So we stock a wide variety of Morningstar product. So most of the time, if we get an order in, before noon, it can ship out that day if it's something that we stock. If it's something that we special order, it takes just a couple days if Morningstar has it in stock for us to get it in, and then we can ship it out to you. So the longest lead time would probably be a week, unless Morningstar, for whatever reason, which is pretty rare, doesn't have that item in stock. Then we would let you know what the lead time would be for that particular product.
Okay, great, thanks.
Mm-hmm.
Let's see, we have actually a suggestion that came in from Bob. Said you need to emphasize that cooling fans are not only unreliable, they make noise. Okay, so I didn't, yep, good point. So I didn't make that point. Anything we should add to that, Doug, or pretty much I should correct that in the slides because that's a good point. Yeah, again, Morningstar doesn't have cooling fans. They're passively cool, but other charge controller brands do have fans, and yeah, noise could be another issue.
We could do sound effects next time.
We'll try to work that in. Let's see. Here's a question. Do you have a controller to control a second backup battery? Question coming in. So I'm not quite sure the answer to this, Doug. We might have to take this one offline. Do you have a controller to control a second backup battery? Maybe, not quite sure. Maybe.
Well, it really depends on a few factors. The SunSaver Duo is capable of charging two 12-volt batteries. So that would be, and they can be different types of 12-volt batteries. So you can have a single array operating with two different batteries. We also have tech support information on our website and a document on how to use a single array and to charge two batteries using two different charge controllers at the same time. Typically, you'll need some extra circuitry like diodes and things to prevent any problems in the circuit. So that is available on the support website if you were to look at if you were to look at the support documents. So there's a diagram available for that.
Okay. Thanks very much, Doug. I'm looking at some of these other questions. Boy, we got a lot of them. There's a question coming in about the 30 amp MPPT. Several questions about it. Is the 30 amp now available on the market? Yes, it has been for quite a while now, but it is our most recent version. So yeah, a lot of people don't know about it, but yeah, absolutely. The 30 amp TriStar MPPT. I think that's what he's referring to. Then the other question associated with this, actually I guess this is really going, no, this is more for the TriStar. Question is, what is load control? You want to take that one, Doug, and just explain that?
Sure. So for DC loads, you would probably want to have a load control built in, which is built into several products like the SunSaver, ProStar, and the smaller products have load control generally for many of the products. Some products don't come with load control, so you have to provide separate load control. Basically, it prevents over discharge. It's a low voltage disconnect built in that will generally operate at 11.5 to 11.7 volts, and then reconnect at like 12.6 volts or so. So it's basically there to prevent over discharge and keep your batteries healthy. One of the reasons that the TriStar and TriStar MPPT controllers do not have LVD built in is that they're often used with inverters which have their own LVD. So it's kind of an added cost that didn't really need to be there. So we also have a relay driver that can be used if you want to prioritize. There's four relays that can be driven with the relay driver, and you can prioritize low voltage disconnects, so you can have certain loads that are more critical that would stay on a little longer, or the relay driver is also good for timing loads and things like that. So we also have lighting features on several of our products like the SunSaver MPPT and the TriStar in the load control mode.
Okay, great, thanks.
And the Sunlight too has the lighting options.
Okay, terrific. I have another question that came in. It says, why would you want to use a parallel input for the TriStar MPPT 600 volt controller? So you want to go ahead and address that?
Okay. So basically, with bigger arrays, if you have a bigger system, with our TriStar MPPTs, there's no problem connecting multiple controllers to the same batteries as long as they have separate arrays. So it's like if you have 2 3-kilowatt arrays, you can connect one to each controller, and it works great. And so sometimes that will work better because you have 2 MPPT trackers going on for a larger array, so you might like that. But other times you might have sizing problems. So having a single input lets you do things like put 3 strings into 2 controllers. It also allows you to use a single ground fault protection device with multiple 600 volt MPPT controllers, and it's also the first parallel feature like this in solar that can operate with real-time operation between the master and slave controller, so that it actually uses Ethernet for real-time tracking, so you don't really lose anything. The parallel inputs act as like it's a single controller acting in simultaneous operation at the same time. The controllers will operate together, not just like following the other one, but actually operating in sync.
Perfect. Great, thanks. I know we're getting close on time here, but I want to see if we can just get to a couple more. Question came in, can Morningstar controllers be used in a system with another brand of off-grid inverter? So John or Doug, do you want to address that? Who should I send that to?
Well, Mark,
Oh, wait, I'm sorry. Okay. Go ahead. John?
Yeah, we would certainly spec Morningstar controllers with any brand of inverter that met our customers' needs. So certainly can be used with a Magnum, with an Outback, with a variety of other even smaller inverters depending on the customer application.
Okay, perfect. Good enough.
We
Anything else, Doug?
We actually have a system here at the office with 2 TriStar MPPT 60s and an XW grid-tied battery backup system, which operates fine. One of the things we do is just set the regulation voltage a little higher, so generally it will just sell right through to the just like any other grid-tied with a controller would. You do lose maybe a little bit of the grid-tied battery backup interaction that might not be quite as good, and it won't be on the same meter. But generally, it operates fine for any battery-based inverter, since they're really just independent circuits. One's charging, and one can be doing the loads with the, or they can both be charging. So it gets a little tricky trying to coordinate the charging in some cases. So you want to be aware of that.
Okay, thanks for the question, and thanks for the answer. I think we've got time for just one more, and then we're going to have to wrap up. So this one I'm going to direct to Backwoods Solar. We have a couple of questions about shipping to different geographies. So either Sequoia or John, do you want to address what geographical locations you ship to or do not ship to? This would include everything from one.
Sure, this is Sequoia.
Yeah, go ahead. I'm sorry.
Yeah, this is Sequoia. We ship all over the world. Domestically, U.S., Canada, those are pretty easy areas for us to ship into without a lot of extra paperwork. But we will ship to foreign countries, Central and South America, Africa, just about anywhere. And we have our own customs broker that we work with that can handle a lot of the paperwork as well.
Terrific. Well, I think with that, I'm going to wrap up here. So thanks, Doug, John, and Sequoia, and everyone else that joined us here today. And we will see you next time. This concludes the broadcast. Thanks so much for attending.
Thank you so much. It was great.